This is Andy Barrett of polyphys.com introducing an app that depicts matter waves. Actually, this app is a clone of a previous app I've made, and I'll put a link to both apps in the description. The original app shows the interaction of confined charged particles in what is essentially a plasma. The new app is the same except that the matter wave representation of each particle is also shown. In this framework, black and white correspond to an amplitude of 0 and 1, whereas the color of the wave corresponds to its phase, from 0 to 2 pi. The phase of one of these Gaussians changes with respect to space and time according to the underlying particle's momentum and energy, respectively. The masses of the particles can be adjusted using the slider on the left. When the mass is 0, the temporal frequency of the particles depends only on their momentum, but when the mass is non-zero, their temporal frequency is determined by this equation from special relativity, omega squared equals k squared plus m squared, where k is the momentum and m is the mass. The motivation for this app is to look for a relationship between wave mechanics and Newtonian mechanics. Certainly this application of the idea of matter waves is naive. For example, it doesn't take into account the effect of potential energy on the temporal frequency. But I do get some insights from it. For example, the black dots that we see here in this rotating interference pattern. From my perspective, this phenomenon is emergent because I didn't explicitly program it to be there, and to me this suggests certain insights. The width of each Gaussian peak can also be adjusted using a slider on the left. The peaks can be made very large so that the interference between them can be studied. They can also be made very small, and this allows you to study the phase relationship between adjacent particles. So one thing we can do is after the system's equilibrated, we can set all the phases to 0 and perturb one side of the system and watch how that perturbation propagates through the structure in terms of its effect on the particle phases. So that's all I wanted to say about this app. This was Andy Barrett of polyphys.com. Go to the site to play with this app and many others that I've made. And if you like my work, then please consider making a donation so that I can keep this project growing. Thanks for watching.